So we were saying that the second equation we will write is the equation along the direction of motion in order to determine the acceleration of the box. So we project forces along x. As we said, force P, which is inclined, has a certain horizontal projection. The horizontal projection is 400 cosine 30. Minus the friction force, which is 0.3 times the normal, equals to mass times A. We already calculated and see from sum of y equals 0. Okay, so we can just now calculate A. Here, for example, we obtained little bit different values because they used 9.81 for G instead of 10. It's fine. You can, with me, you can use 10 to simplify calculation. Okay, unless they specified for you in the problem to use G equal 9.82. Now, when you solve for your equation along x, you get your acceleration. Now, how to get your velocity based on A? What should you do once you have A?
Integrate.
Integrate. طيب, is A function of time or it is constant with time?
It's constant.
Why?
Because we got it independent of time, so it's
Yeah.
always like that.
Look, because all forces here applied are not changing with time. If you had, for example, this force equal to 400 t, for example, so if this force was varying with time, then the acceleration will vary with time, and then you need to have integral procedure. You cannot use the formulas of constant acceleration. However, what is happening here is that you have constant forces, which will lead to constant acceleration. And you say, since A is constant, I can use the formula that V is equal to AT plus V0. And since I'm starting from rest, V0 is 0. So my velocity is A times T. And in particular, I am interested at the velocity after 3 seconds. So all I have to do is to replace T by 3. Okay. Any question on this problem?
Doctor, just to make sure, they told us that it started from rest.
Yeah, it's starting from rest.
Yes,
This is why V0 is 0, okay? Let us consider another example. You have the following system, consists of a baggage truck A that has a weight of 3,600 Newton and tows a 2,200 Newton cart B and a 1,300 Newton cart C. For a short time, the driving frictional force developed at the wheels is Fa equals to 160 T, where T is in seconds. If the truck starts from rest, determine its speed in 2 seconds. What is the horizontal force acting on the coupling between the truck and cart B at this instant? So if you look at the following figure, you have a system of 3 cars, small cars, okay, that are connected together through couplings. And they told us that the driving force on this system is only acting on A. You know that for some cars we say no, عندنا 4-wheel drive أو sometimes بيكونوا بس بيشدوا من قدام أو بس بيشدوا من ورا. So it depends on the car, okay? Whenever you have a 4-wheel drive, then you have a friction acting on a driving friction acting on the front and back wheels. However, in some cases, you have some cars where driving friction force will act only on the front wheel, okay? While for other cars, you have driving force acting on backward wheel. So it will depend on the car. Here, they are saying that for this system, the driving friction is only transmitted to car A, to wheels of car A. Okay, what is a driving friction? In general, you know that friction, for you, friction means opposition of motion. This is true, but how a friction can become a driving friction? Because look, it will oppose what we, if you want, it will oppose motion of the wheel, but will favor motion of the car. How? Whenever you have a car, if you look at the wheel motion, your wheels will rotate. Okay, so if you are at rest and you want to move your car, your wheels will start to rotate. Once the wheel starts to rotate with respect to ground, then they will act, if you want, on the ground. They will put a force on it in this direction, and by action reaction, the ground will act on the wheels in this direction. Okay, so friction here is, if you want, is trying to oppose rotation of the wheel. So it's opposing rotation of the wheel, but by opposing the rotation of the wheels, it's favoring translation of the car. So this friction is resistant to rotation of wheels, but it is driving translation of your car. This is why we call it driving frictional force. So whenever we tell you the friction on a car is a driving frictional force, this means that it acts in the direction of motion of the car. Okay, and whenever you say I put the brakes on, then friction will be opposing translation of the car. It will be in the opposite direction, because when you put the brakes on, what will happen? You will create a locking effect on your wheels. You are preventing them from rotating. And when you if you want, reducing the rotational effect, then your wheels will slide. And as your wheels will slide, then the friction will now oppose the sliding effect, and it will be in the backward direction. Okay, so here, because they told us that the driving frictional force is developed at wheels of FA, and it's a driving force, this means that it will act in the same direction of motion. So if I want to represent FA, this is FA. Now, they want me to find the speed in 2 seconds for my system. And also, they want me to calculate what is the coupling forces between A and B. So what is the force acting here between A and B? Now, how to think in such problem? The first step in such problem is to draw the free body diagram showing all forces acting on my system. I have the force acting at A. I have, of course, the weights of my 3 cars. And of course, I have the normal reaction from ground, but I can, normal reaction is at wheels level, but I can say I can take a resultant normal for car A. This resultant normal will oppose the weight of A. Similarly, a resultant normal on wheels of B will oppose the weight of B. And the same for C. But as you can see, all weights and normal forces are along vertical direction. So they are not contributing to the acceleration, because your system is moving in X. So all of these forces are in Y, and they will cancel out along Y. Okay, so this is why I don't need them for my analysis. For my analysis, I will just consider the X direction to find the acceleration of my system. What will be my system as a first step? I will take A alone, or I will take the whole system, A plus B plus C. What do you think?
But Dr. Maiza, if it's connected, then they are all the same object.
Exactly. They are connected together. They are moving at the same acceleration. So it's better for me to take the whole system. You know why? Because if I take the whole system, what is my only unknown?
Acceleration.
Yes, because if you take your whole system, the only force acting in X is Fa, and and Fa is given function of time, it's 160t. So the only unknown that you have is the acceleration A. Okay, and now to get A, you say, you specify always your system. What is my system? My system is A plus B plus C. Okay, so when I write sum of forces equal MA, I should take the total mass. Okay, so now I write FA is equal to MA plus MB plus MC times the acceleration of the system times A. Okay, and then I can say that what is my acceleration? The acceleration of my system is equal to the force Fa, which is 160t, over the total mass. And since they gave me the weight of A, the weight of B, the weight of C, to get the mass, I divide by 10. So the weight of A will be 360. The weight of B will be 220. And the weight of C will be 130. Okay, so I got now the acceleration of my system, function of time. Okay, so I get that A is a certain, I can calculate this constant. It's a constant C function times T. So A is linear with time. Now, since they asked me to determine the speed in 2 seconds, what I will do here? What is my next step? Yes, I will integrate. Exactly. I will say that A is dV by dt. I can do separation of variables. So I write dV equal to constant, which I calculate, times T times dt. And now I integrate both sides. For dV, I integrate from what? They said my system starts from rest. So I integrate from 0 to V. And for time, I integrate from 0 to, what is the time I'm interested in? 2 seconds. So I integrate from 0 to 2. This will give me V at 2 seconds. Okay, so I can say that V at 2 seconds is equal to the constant times T square over 2 between 0 and 2. So you replace your boundaries. You get that V at 2 seconds is C times 4 over 2, so it's 2C. So the velocity after 2 seconds is equal to 2 times the constant, and the constant is 160 over 360 plus 220 plus 130. Okay, in this way, I get the value of the speed in 2 seconds. Now, what about the coupling force between A and B? How can I find this force? What should I do?
We take A as a system and study the forces on it.
Yes, very good. Look, you remember in statics for a beam, whenever you want to find shear and bending moment, what you do? You do a cut, because shear and bending is within your section. So whenever you consider the whole beam, there are internal forces and couples. However, when you cut, then you can see what is happening in the section. You can calculate what we call them internal forces. So always, to calculate an internal force, you should cut your system. And since I am interested in the force in this coupling, I should cut at this level. So or I take as system A or I take B plus C. It's equivalent. You know why? Because on A, okay, what are the forces? It's F of A and it's the coupling force. So F of B on A. Now, if you take system B plus C, what are the forces acting on B plus C in the horizontal direction? If you take the system B plus C, what is the force acting along X?
FA on me.
Very good. FA on B, and it's by action reaction opposing F of B on A. So this is the force of A on B. Okay, so now once I did my schemes, I can take or the system or this one, and of course I obtain the same result for any of the two. Now why
بس
if
بس
yes
مش المفروض اف بي اوف اي واف اي اوف بي انه بالعكس دايركشن، لانه اف اي اون بي is to the right.
FA on B is to the right. لا كيف؟ لا، ما انت كيف ماشي السيستم هيك صح؟
اوكي انا بفكر ماشي اليمين.
No ال A هون ماشي in the towards the left system. Okay, so because the system is moving towards the left, A عم بيشد على B plus C towards the left, by action reaction B plus C is doing a force on A towards the right. Okay,
now it's clear. Yes, thank you.
okay, now مثل ما شايفين هون وقت ناخد A لحاله بيزيد عنا unknowns جديدة. يعني this is why in the first step we didn't consider the system A alone لأنه شو كان عنا unknowns؟ كان عنا acceleration unknown and the coupling force unknown. But now since we have taken first the whole system, taking the whole system will cancel out internal forces. بضل unknown الوحيدة بس A. And once we got A, now we can take A alone or B plus C alone, because now when we take A or B plus C, we introduce a new unknown اللي هي coupling force between A and B. Okay, so now if I consider A system, شو بتكون equation? If my system is A only, I have plus FA minus FB on A equals to what? إذا أنا السيستم تبعي A وحطيت الفورسز on A, when I say sum of forces on A and X, this is equal to what?
مش الماس تبع ال A times the acceleration of the system.
Very good. I only take the mass of A now because A is my system only. So I do A times the acceleration. A is the same for A and for B and for C. And A is the one that I already calculated in the previous step. Okay? Now, since I have A from previous step and I have FA, the value of FA, and since they want me to determine at 2 seconds what will be the coupling force, so I have a function of time. إذا بتتذكروا هي C times T. So I just replace T by 2 seconds. So it's MA times 2 times my constant C. So I can calculate this term, and then I can say that F of B on A is equal to FA at 2 seconds. I replace here T by 2. I get 320. So F of B on A is 320 minus MA, which is 360, times 2 times the constant. Okay. Now, this is the first method to get the coupling force. The second method is to say, let me consider system B plus C. If I take this system, the only force is F of A on B. And now, if I write in Newton law, what do I get? I get plus F of A on B equals to what? It's equal to what?
مش الماس تبع البي والسي
Okay.
times acceleration.
Exactly. لأنه أخذت B and C as sister, يعني I should do MB plus MC times A. And you can check that you will get exactly the same result. Okay? ليش ما أخذت B لحاله? Who will tell me? Why I didn't consider just B as a system?
لأنه بصير بدنا ناخذ نحن كمان فورسز على سي وبتفوت القصة ببعضها، يعني فينا ناخذهم السيستم ونطبق الاكسلريشن عليهم بس ناخذ الماسز مع بعض.
Yeah. إذا بناخذ B بصير في two coupling forces، بصير في F of A on B وبصير كمان في F of C on B. يعني بدل ما يكون عندي one unknown بيكون عندي two unknowns. And if I have two unknowns, then I cannot solve in one equation. بصير بدي additional relation. شو بعمل ساعتها؟ شو هي additional relation؟ كيف بجيبها؟ مين باخد system؟
نعمل على السي.
Exactly. بصير بدي اخد C كمان as system وقول انه for C I just have f of B on C. ساعتها بكتب two equations with two unknowns يلي هن f of A on B و f of B on C. Okay? نحن by action reaction هولي equal in magnitude but just opposite in direction. ف we can do take B بس ساعتها we are increasing the steps because we need another equation. لو سألونا what are the two coupling forces يعني مجبورين بالآخر نعمل two equations. بس بما انه بس سألوا الcoupling here to facilitate or we take A as a system or we take B plus C as a system. Okay? Any question on this? Okay. Another problem. You will see here that all concepts we introduced before we'll use them. يعني chapter 12 is essential for chapter 13. But for 13, we just add a Newton law. Okay? So for example, here, you have the 100 kilogram block A is released from rest. If the masses of the pulleys and the cord are neglected, determine the speed of the 20 kilogram block B in 2 seconds. Okay? Can you give me a quick method to know which block will move down, which one will move up? Will A move down or B move down?
I guess A will move down because it has a higher mass.
Mish because it has a higher mass. You know why? Because I can give you an example with A having higher mass.
That's what I was.
Okay.
I was hesitant.
Look, whenever you don't know how the motion will take place, you can just assume direction of motion. And from your calculation, you will know if it's positive or negative. But here, how you can make sure? You can say, what should be, and let us say the weight of B is 20 kilogram. What is the weight of A to have equilibrium conditions? Can you give me the value? Assume equilibrium. If you have equilibrium, what will be the tension in this cord here?
equal the tension على A.
Equal لا مش equal للtension على A, equal للweight of B صح؟ انتو إذا block B is not moving, this means what? This means that the weight of B اللي هو 200 Newton should be in equilibrium with the cord tension صح؟ يعني the cord tension in this cable should be equal to 200. طيب, if the tension in this cable is 200, we know that for a cable, for a frictionless cable, the tension is the same everywhere, صح? So now, if you take the pulley C as system, شو حتكون التنشن in this cord here?
400.
400. Why? Because when you cut at this level, you have 200. When you cut at this level, you have also 200. So in total, for your pulley to be in equilibrium, this force will be equal to 400. وساعتها for block A to be in equilibrium, what should be
40.
the mass? 40. Very good. 40. So if the mass of A is 40 kilogram, for a mass of B equal to 20, I have equilibrium. If I put on A mass larger than 40, شو بيصير?
It will go down.
A will move down. If I put on a mass smaller than 40, mean A will move
Up.
Okay, so if I tell you the mass is 30 kilogram, مظبوط 30 is larger than 20, but who will move down? B. Okay, why? Because here you have 2 times the tension opposing motion. مش T بس, you have 2T here. Okay, so now because the mass of A is 100 kilogram, which is larger than 40, and you can be sure that A will move down and B will go up. Okay, so this small analysis can tell you that this is the direction of motions. You can make sure of this from calculation of A. Okay, so in this problem, they want you to determine the speed of block B in 2 seconds. You know that from chapter 12 كانوا هن يعطونا مثلا the speed of one block ونحن نجيب الثاني by relating them. But here they didn't give us any velocity. They just told us to find the velocity of B in 2 seconds, knowing that the system is released from rest. So because they didn't give us any information on the speed of A or B, we should try to calculate velocity. And to calculate velocity, we need to find what first?
Acceleration.
Acceleration. And to find acceleration, we should think about which law?
Newton's second law.
Newton's second law. Very good. So now, in such problems, the first step to do is to draw the free body diagram of forces. I will start with block B. What are the forces acting on B? The weight of B and the tension of the cable, of the first cable. I will call it TB. Okay. Now, because the pulleys are massless, even if your system is accelerating, since the pulley is massless, what is sum of force on pulley? You know that sum of force of pulley is mass of the pulley times acceleration of the pulley. So even if it's accelerating, when the mass is negligible, then what is sum of force on it? 0. So this pulley will allow you to relate tension TA to tension TB. Okay, so you take the pulley as your system and you say, since sum of forces on my pulley is equal to 0, then I can relate TA and TB. So TA should be equal to 2 times TB. Okay, and now when you take your block A, what are the forces acting on it? You have TA and you have the weight of A. Okay, then what are your unknowns? Let us determine our unknowns. TA, TB, but we already found a relation between them. So this is my first relation. My unknowns are TA, TB, acceleration of A, and acceleration of B. Okay, until now I found one equation. Since I have 4 unknowns, how many equations I need? 4. Can you tell me what will be the remaining 3 equations, do you think?
First one is we did the mass on A and B.
Okay.
Then we should do the one that we used to do in chapter 12, which is S of A plus.
Yes, very good. Whenever you see a pulley system, you should say that I can relate acceleration of A to acceleration of B. So the second equation is from chapter 12, because chapter 12 will allow you to get the relation between AA and AB. We'll do it together in a while. Okay, So this is my equation 2. What are the two remaining equations? Whenever you have forces and acceleration as unknown, always think to relate them using what? Newton law.
Newton.
Newton. So we'll write Newton for B and the Newton for A. So we have two additional equations. We can write two Newton laws. Okay. So in total, then we get 4 equations. Okay. So if I consider my, as your friend said, the second equation is to put a coordinate system and then relate acceleration of A to acceleration of B. Here it's relatively simple. You have block A and block B. This pulley center is fixed to the ceiling. So I can take, this is my reference line. This is my reference line. B is moving vertically, so I need a coordinate for B. A is moving vertically, so I need a coordinate for A. But because center of pulley C is related to block A, it's enough to take one coordinate for both. I will call it SA. And now, if I move along my pulley, my pulleys, my chord is of length. First, SB. This part is, this is a constant, okay? Then when moving here, it's SA, and this is a constant. I move again a distance SA, and this is a constant. So in total, I can write that SB plus 2SA equals to a constant. And then if I derive 2 times with respect to T, I get that AB is equal to minus 2 AA. Okay, so this is my relation number 2. This is my relation number 2. Okay, now the Newton law here is very simple because I just have for each block just tension and weight. Okay, so if I take block B, I just have tension of weight of B down and tension of B up. And please, please do not have any confusion. How is your coordinate system? Downward. Yani AA, AB are expressed in which system? In the downward system. So don't write sum of forces along the upward direction. And if you write sum of forces along the upward direction, لازم تكتبه minus MBAB because AB is measured in this coordinate system. So to avoid any confusion, stick to your system. I will take the positive direction downward. So for B, when I write in Newton law, it's plus WB minus TB equals to MB times AB. And AB is expressed in the downward system. So if you get AB negative, this means that you're accelerating upward, and this is expected. You expect to get AB negative and AA positive because we said that A will move down and B will move up. So this is equation number 3. To close the system, we need a force relation. The force relation will be Newton law on A. And also for A, how is the positive direction of coordinate system? Downward. So I will write a Newton law along this direction. So I have plus WA minus tension at A, which is related to TB because I demonstrated that TA is equal to 2TB, equals to MAAA. So now, if you use your previous result, you can replace TA by 2TB. And you can replace AB by minus 2AA. Okay. Then you can get just 2 equations with 2 unknowns. You solve for TB, you solve for AA, and then you can get all your unknowns. TA, TB, AA, AB. And once I have the acceleration of block B, to get its velocity in 2 seconds, I simply say all my forces here are constant. So AA and AB are constant. This is why the velocity of B is acceleration of B times t plus V0. And since I released my system from rest, V0 is 0. So I can get the velocity of my block in 2 seconds. Okay, so this chapter combines several chapters. It combines chapter 12 and 13 in order to come up with a solution. Any question on this?
Thank you, Professor.
Okay, welcome. Thank you. Bye.
Thank you.